Hello. We're going to do diagnostic test page 21, and we are on questions 28, 29, and 30. So let's do it. A video game company is interested in the proportion of people playing one of their online games who would be willing to pay for an enhanced version of the game. The plan would be to market that if they know that more than 40% of the current users would pay for the version. So they've got to have convincing evidence. So let's keep reading. They plan to survey a random sample of 200 players, so that sounds like quite a bit of people, to decide if they would in fact want an enhanced version. What is the appropriate null hypothesis in this situation? So, they don't really have a hunch, but they have a belief. Or we can at least write down what we believe. So if in fact we believe that the truth is that the true proportion of people that are willing to like this game is 40%, then we write it like that. So we say the accepted truth is that the true proportion is 40%. And then my alternate hypothesis, I'm trying to figure out, do I have convincing proof to actually say that that proportion is something more than 0.40? And that's my H sub A. So as I look through the choices here, I'm feeling good because it asks, what's the null hypothesis? So I kind of have to know vocab. The null hypothesis is not the alternate hypothesis, it's this one. It's that one right there. I guess you can't see it. Okay, so hopefully you can see that there. So now we look to see which choice matches that one. And I notice that the one that is more than is choice D. Good. Wait. No. D is my alternate hypothesis. So if you put D, you went for the alternate hypothesis. The null hypothesis is choice C. So that's the choice I'm going to pick. Next question. A newspaper. So it says, a newspaper claims that the proportion of people using public transportation is 0.39. So we're going to accept that as the truth. An environmental group disagrees, stating it is smaller than the claim. So they have a hunch. Their hunch is it's something smaller. I'm going to use a less than sign. So my hunch is P naught, or H sub O, P is equal to 0.039, just like the last question. I have an accepted truth, and I have an alternate hypothesis. So H sub A is that value P is something smaller than 0.39. And so I'm going to take a moment to glance through my choices now that I understand what they're asking. And I notice that B, C, and D have the correct null hypothesis. And the one that has the smaller than sign is D. So I'm going to pick D. There we go. Loving it. Two easy questions, very similar. Last question. So I take a look at question 30. A scientist wants to use data from a survey of 1,000 randomly selected voters to determine whether there's a relationship between gender and whether or not a person voted in the last election. So I need to ask myself, well, is this quantitative or categorical? So when I think this through, I say to myself, gender. I'm going to ask, are you a male? Yes or no? Assume it's a yes or no. Ask the person if they voted in the last election, and we're only going to take a yes or no answer. So we end up going, did you vote yes or no? Or what is your gender? And so we have two categorical pieces of data. And so unlike a quantitative chart with a least squared regression line, I can see if there is a correlation between two variables. I can't really do that with categorical unless I do a chi-squared test. So I'm liking B and D, and it's definitely not a one proportion test because I end up having two proportions. So I definitely think this is a chi-squared test because I can see whether or not there's a correlation between these two. And I say to myself, goodness of fit doesn't make sense because goodness of fit is when you only ask one question. So the only one that makes sense here is a chi-square test of independence. Now, if we did this in our calculator, if they gave us numbers, we'd set up a two-way table. And so that'd be another way. Well, how could I collect this data if I pretended I actually did ask the questions? I can make kind of a pretend graph, and that would be a two-way table. So if I was advising a student that this was something they were interested in, I'd say, hey, go ahead and make a two-way table and calculate the number of men and the number of women. And then if they answered the question, yes, they voted in the election, or no. Notice this is definitely reminding us of a chi-squared test for independence. Thanks again for joining me. Best of luck on the exam.